Okay, what I'm showing here is about more or less the same time the opinion of a different scientist, David Spiegelhalter, who was also a member of the scientific committee advising the British government about what to do in relation to the COVID pandemic. And you can easily see that these are very two different perspectives and views about the subject. Spiegelhalter says about the idea that governments have to follow the science is, how can you follow the science if science doesn't tell you what to do? And also highlights the fact that different experts have different opinions about what to do. Now, I just use this, but I think that most of you could easily find a very different perspective on the subjects and strong disagreement, a lot of uncertainty, even acknowledgement of uncertainty. Now, the question for you, which I won't answer today, but you can think of, is the following. Can science speak with one voice? And the second, should science speak with one voice? And thirdly, if you know the science, do you know what to do? These are three questions important because they are at the core of the relation, or what I said at the beginning, the coevolution between the modern state and science since after the treaties of Westphalia that established the regime about modern states, about the role of knowledge and science, etc. Now, when something like this happens, like in the case of the pandemics, when you have so many different and contradictory opinions and so many controversies, people are surprised. And when I say people, I refer that not only the population is surprised, but also administrators are surprised, politicians are surprised, and even scientists are surprised. And from there, you get this idea that science has to apologize because it was unable, in the case of the pandemic, to speak with one voice. Now, but we were not surprised, because these things happened already in the past. Next, please, Max. Okay, as you see, during the 80s, we worked about a controversy that had to do with the possible relation between emissions from a reprocessing nuclear establishment in Cumbria in the UK, Sellafield, and the existence of clusters of child leukemia. Okay, as you can see here are the references, so you can check by yourself. What you have is, and that case was a kind of a standard in the analysis of risk assessment and the evaluation of new technologies, etc. And I could see why it generated debate. One is about risk assessment under conditions of uncertainty, irreducible uncertainty, the limits of epidemiology and environmental monitoring in contested settings. And here I have to say that in that case, you had epidemiologists arguing about themselves, you had modelers, radiobiological modelers arguing about themselves, and you have doctors, medical doctors arguing about themselves. It was not an argument across disciplines, but it was not only across disciplines, but also internal to their own disciplines. And as you can see, epidemiologists, medical doctors, modelers, almost the same type of groups or disciplines that we had already in the COVID case. And you can see also other elements, how they reconcile scientific evidence with public perception and local experience, and the importance of transparent participatory governance of controversial technologies. That was very important research that we did. We worked with some other colleagues at the University of Leeds and the United Kingdom National Radiological Protection Board, because what we learned was very important for the work we did in the next 40 years. And this is, you are in a situation of high uncertainty, small numbers, complex causality, incomplete knowledge of radiation effects, high stakes, children's health, economic future of a region, credibility of nuclear policy, value-laden debate, safety versus industry viability, trust in experts versus local knowledge, and need for a broader participation between technical experts. Okay, now, again, so we have here something we knew already 40 years before COVID. And we say that this belongs to a category of knowledge that we can call uncomfortable knowledge. It is uncomfortable because institutions and experts and administrators and even people are unable to cope with. Now, then, during the 80s, when we were discussing this controversy, people again were surprised. How can this happen? And the Black Inquiry, who was, as you may know, is a way in which the UK used to handle these issues, and it was a royal commission headed by this guy called Douglas Black. It was not black because of the color, but because of the name of the judge that was leading them, came to a conclusion. It was not proven, which is interesting. It didn't say that there was a link or there was not a link, but it's simply not proven. So there was not enough scientific knowledge, evidence, in order to establish with reliability if there was or there wasn't a link, okay? Now, as I say, 80s people were also surprised. But next, Max, please. And again, we were not surprised because during the 70s, a physicist, a nuclear engineer at the Oak Ridge National Laboratories, Alwin Weinberg, published an article in a journal called Minerva, where he talks about science and transscience. I don't know if you know the term, or you're familiar with the term transscience. Okay, now, this is interesting, and you can see, oh, you are all very young, I mean, but this is the way in which the citation index appeared at the beginning, before the internet. If you look here, this is taken from something that came in hard copies, right? And the citation index was done in a totally different way as then it was developed. Okay, so that's the curiosity. And here already you could see that Weinberg, looking at the problem, which is quite similar also at what we were talking before, at the experiences of the radiation and the COVID, tries to establish if science can have a robust result, okay, a robust result, dealing with emissions from a nuclear power station working normally. We are not talking here about an accident, okay? This is important. And environmental or health effects. And he comes to the conclusion that science can't do it. And I invite you to look carefully at Weinberg's work, because he was a member of the Manhattan Project, developing the nuclear bomb in the 40s, and then he was at Oak Ridge National Laboratories, where they were working with even also with nuclear artifacts. But he was also one of the first to write a report on climate change, well before it was on the agenda, international agenda. Now, here, just to make it short, he called this transscience. And I want to highlight two other references here. One is by Harvey Brooks, who was also became later a director of the Kennedy School, Harvard Kennedy School of Government. And Harvey Brooks, of his experience at IASA, which was the International Institute of Flight Systems Analysis in Luxembourg, he uses systems analysis, the work especially on energy sources, to say those systems are also transscientific, and because they are complex. Because they are complex systems of equation. And he says, as you might know, that since Poincaré, Henri Poincaré, who wrote at the beginning of the 20th century, yes, a report on the three-body problem, where he argues that they are simple problems, complicated problems, and complex problems. I'll come back to this a bit later. But there is also another quote from Ruckelshaus, Bill Ruckelshaus, who was the top administrator twice of the Environmental Protection Agency. And he says that when he came to the Protection Agency, he thought that he was going to deal with scientific and technical problems. And he said that most of the problems he dealt with were of the kind of practical and political problems. So he defined transscience, and this is, I want you to think about it, as a problem that can be expressed scientifically but cannot be solved scientifically. Interesting. Okay? So, of course, as you know, I'm a philosopher of science. But that is very interesting. I could have a seminar of a year seminar discussing what does it mean to express a problem scientifically, and what does it mean to solve a problem scientifically. It's not so easy or not so simple. Now, we can come back to this if you are interested, but let me Max, please, the next slide. Well, this is what I call the problem-solving strategy of the modern state. And I'm sorry I don't have time, but I invite you to look at this more closely. What changed everything was the treatise that I mentioned before, that changed the nature of governance in Europe around 1650. And there it was established what we can call a privileged relation between the modern state and the beginning, the emergence of a scientific knowledge. Okay. At that point, it was based on the state, and the elements of legitimation were based on a duality, in what we call the facts-values duality. And there were established institutions to handle facts and institutions to handle values. The institutions that handle values are, for example, today parliaments, okay? Whereas institutions that handle facts were, let's say, at that time, universities, the scientific societies like the Royal Society of London, and then all the research institutes, etc., etc. And the idea was that if you had a practical problem in society is you have to translate it into a technical scientific problem. You solve the technical scientific problem, and you consider that the societal practical problem has also been solved. Okay? That is what we can call the model of legitimation, of political action and decision making of the modern state. Now, that worked quite well. And without wasting too much time, Europe, that until Westphalia was almost a conglomerate of failed states with, the pest, hunger, famine, and wars, constant wars, became, in a short time, an imperial power in the whole world. Okay, now, even small European countries like Portugal or even Netherlands and so on became imperial and colonial powers. I won't go, of course, when you say success, you said in some terms. If you use other terms, that implies imperialism, colonialism, and all the rest that things we discuss today. So there is this ambiguity of success. From where this comes and how do we justify this? Well, because it was assumed that in terms of, I mentioned before, the distinction of Poincaré, that societal problems were simple or even complicated. And also the technical scientific problems were simple or complicated. From where does it come? Max, the next one, please. Okay, another click, please, Max. Okay, so it comes from, I choose in this case, Galileo Galilei. In this classic text, in the bottom, you have the Italian for the original Italian from Galileo, and the other is my translation. Okay, so what Galileo argues is that there are what he calls primary and secondary qualities. Primary qualities are those that you can measure. For example, the longitude, for example, the mass. The other qualities that come through our senses, okay, are secondary qualities, subjective qualities, and therefore have to be dismissed when we are doing science. Is that clear? And he gives the example of a feather. He says, I tickle my bird with a feather and I feel it tickles. Is that important? And he says, no, it's not important because it's my bird and it tickles me. So therefore, we have to dismiss it. It's the same if the feather is white. Well, white is not important because I see it as white, okay? So that's the idea, and he invented modeling, actually, okay? With this idea that we have to concentrate on the primary qualities and not the secondary one. Now, why is this important? Because it is a reduction of complexity, okay? So Galileo and others like Descartes and Hume and other people at that time that were creators of the modern scientific method realized that there was a problem of complexity and uncertainty. So they tried to reduce that in order to be able to provide a result and quantitative results. So he proceeds by doing two types of externalization. The first externalization of Galileo that you can recognize immediately is you isolate the system you are studying from its context. assuming that the system that you're studying is almost isolated and almost stable. So the relation between the system you're studying and its environment, context, universe is not important. It doesn't affect your work inside that system. And the second externalization that you do is you eliminate ourselves, our bodies. So our bodies are irrelevant, our senses are irrelevant for the work we do. And that is we call scientific work. And this from there, it comes the idea that science is value neutral, is objective, and it can be used as an arbiter. Okay? Therefore, the assumption of the, as I call the problem-solving strategy of the modern state, was to use something that it was purported to be value neutral, objective, and just responding to how things are, not how we are perceiving them. Okay? And in that sense, and because you are interested, I imagine, also in uncertainty, the idea that we are the ones that introduce uncertainty into the equation. Without us, the universe works like a clock. That was the image, okay, of that people have of, you know, how the universe works. Even our bodies work like a clock. So if we eliminate all the biases and all our, you know, our interests, then you'll find yourself with something that it is precise, that you can predict, and you can quantify. Is that clear? Now, again, this was very successful, as I said before. This method was very successful. But now we have to do a leap forward. And please, Max, the next one. So we come to someone that perhaps you're familiar with. And, you know, he was one of the people who introduced the indeterminacy principle, okay? As you know, the discussion, shall we call uncertainty principle or indeterminacy problem? Well, it depends. I'm a philosopher. I say, well, it depends. It's not so important. But indeterminacy is an important term when we are talking about complex systems, right? So in that sense, we already had in a different epoch what they say that we would observe is not nature itself, but nature exposed to our method of questioning. Immediately, and if you follow this line of thinking at the time, you can see that it's no longer Galileo's method, because in this is implied that you might have different ways of questioning nature, okay? This idea that there's not a unique way of questioning nature, which goes back, as I say, to the late 19th century physics and mathematics, arriving to Poincaré and the 20th century with the limits of formalisms, okay? Now, next, Max, please. So, and we come to a definition that I'm sure you are aware of, and you had Mario Giampietro probably also as a speaker, because I think he gave my name to you. And what you have is, we like Robert Rosen, okay? And I'm sure you know some of his books and work, for example, about life itself, and other. But this is the idea that corresponds to our own understanding about a complexity that goes back, as I say, with Jerry, we were originally mathematicians and philosophers of mathematics. So this idea that complexity is the need for many distinct modes of descriptions of a system. In other words, and then we can talk later, we argue that a defining property of complexity is ambiguity. And if you are not familiar with the word ambiguity, it's the idea that there are many different possible and legitimate descriptions of that system. The system is ambiguous, okay? And this idea that in order to try to capture as much possible of a complex system, you have to look at a number of perspectives, a multiplicity of perspectives. So plurality of perspectives is a defining feature. And from that, you can even infer all other properties when you're talking about nonlinearity, etc., etc., etc. Okay, is that I think this for you is simple. But substantially is a complex system cannot be overdetermined. Okay, so all the theories you can build in order to explain are underdetermined that complex system because you need a plurality of them and as many as who knows when. The next one, please, Matt. Okay, so we come back to the idea of what I say the problem-solving strategy of the modern state. And what you have here is that you have a problem. The problem is if the practical problems are complex and the technical scientific problems are complex, meaning it's not a one-to-one relation, but many-to-many, the question is who decides which is the right problem to solve and which is the right solution technique. So it becomes a serious problem for the legitimacy of action and political decision-making in the modern state, which is enshrined in the constitution and legal systems, the Roman Napoleonic Code. Is that more or less, perhaps we can come back if you find it complicated. So what you have is that if it's no longer a one-to-one relation, so you have a problem and you have a solution. No, you have a problem of choice. So the problem is no longer devolved to science, but to the democratic system. Is right? Okay, next please. Okay, and that has become almost common sense, although there is a lot of resistance. I would say that most of the official accredited scientists and experts don't know anything about science of the 20th and 21st century. They are still talking about Galilean science, okay? Now, here I give you an example. Some problem that is simpler than COVID, okay? And it is clean air. So what do we do? When I used to work for the European Commission, you have a problem. I was involved in problems, for example, mad cow disease. Okay, remember the mad cow disease? Okay. Okay, so what you do, you genetically modified organism in agriculture. You call an expert committee who deals with the facts and not with the values. So I had a Norwegian student who was an expert and participated as Norwegian representative in the genetically modified European Commission expert group. So she said, I want to ask a question. Do we need them? Who benefits? And the chair correctly said, these questions are not allowed because they belong to the area of values and not of quantitative risk. So what we have here is something that they call an expert group, in this case in the in EPA, and what you have is that the quantitative evidence has high uncertainty. Irreducible, you can go, here are all the reference, and it comes the conclusion, already in Nature, I'm talking about 2008, okay? It comes to the uncertainty is a policy question, not a scientific question. Because, and you know, I'm a scientist working in a discipline, whatever, and for me, uncertainty is not a problem. It's one of the reasons why I do science. Is what pushes the boundary of our knowledge. So who cares about uncertainty? Oh, you care, you have ways of dealing with and cope and etc., etc. But at the end of the day, if you found yourselves, like in the case of string theory or quantum mechanics and the multiverse, well, that's okay with me. But if the state and the legal system of the state depends on your answer to provide a legitimate policy action, okay, and decision making, you are in trouble. And the question becomes, how much can a certain society tolerate? How much uncertainty in order as a basis for decision making? Is that okay? And next, please, I have to go faster because I'm here. So at this, almost at the same time, people discover that actually any problem can have uncertainty, right? And this is about a book by David Michaels about what he called the fabrication of uncertainty. This idea that in order to fight regulation and big pharma, others, tobacco, remember, classic example of where you create uncertainty, you work and you create. But then the question is it so simple to create uncertainty? Yes. You know, when you have 2 points and you feel that there is only a line that will cover, it's simple if you assume a linear correlation. But it is not so difficult to do research that will produce uncertainty. And if you are looking for a situation where uncertainty can be reduced to quantitative terms, you are in trouble again from a political, policy, and constitutional and legal point of view. Okay, we can come back to this because probably this is a part that's a bit further from your work. Next, please. Okay, not only that, but what we have at the same time is the beginning of what we can call a popular epidemiology. The idea of lay people finding themselves in situations of conflict, crisis, and risk create their own knowledge. Okay, Love Canal, I invite you to look at it as an example because it's the beginning of what we call, at that time, not politically correct, it was called housewife epidemiology, then it changed to popular epidemiology, and now it's called citizen science, which I suppose you are aware with. So that's the beginning. So when you have all this situation, then you realize that people not only express interests and values, they are also creators of knowledge. And not only that, what we see is that the new techno-scientists, entrepreneurs, are not only creating knowledge, I mean artificial intelligence, to give an example, very new. They are also entrepreneurs. They are making money. And I don't have to mention the names. So what you have is that distinction of who creates knowledge and who provides inserts values is no longer simple. It is ambiguous. Both create knowledge and at the same time express values. So this is why we are in a situation where the regime we have to justify decision-making and political action is of the modern state is in total crisis. The way we cannot avoid, can we have the next, please, perhaps? Yes, so I will go. On the basis of that, many years ago, now almost 40, we published a number of articles introducing the idea of post-normal science. I don't know how familiar you are, we can talk, you have all the reference, you can go. But the idea was, if you remember the slide on the case of field, what we have is that you have facts that are uncertain, that you have a plurality of values in dispute, you have stakes that are potentially high, and decisions are urgent. Immediately, you can think of COVID, but climate, and other examples that I will mention a bit later. And the idea, well, this iconic diagram where we say, as soon as you go high systems uncertainty, high decisions that you can go from simplicity to complication to complexity, what you have, the extension of knowledge providers, okay, extends, okay? So you no longer have disciplinary peers judging and evaluating research, but that community extends. I can come back if you are interested. We call that extended peer communities. Okay, I can come back later so I can finish this part. Next, please. Okay, and as I said before, it's not only COVID where you see all these problems that I mentioned before, what we call the mantra of post-normal science: climate change, ecosystems collapse, biodiversity loss, sustainability transitions. And as you see here, it's very clear that Galileo's or modern science externalization don't work anymore. Context is important, but not only context, our bodies are important. Our bodies are important. Next, please. When I say that context is important, I'm not referring also to the universe where the system is only from a factual point of view, but also from the historical, social, political, and cultural context. What do you have today? Situation of intolerable inequalities, social, economic, put whatever you want, weak democratic institutions, look what's going on around us, authoritarian tendencies, and a magical idea about the role of science in society. This is the context in which we are dealing with all those examples I mentioned of complex problems that need a new look, a new perspectives. And we argue that those perspectives are related to what we call extended peer communities, which I can take in a new talk in a new opportunity. Next, please, and this is my last slide. Okay. During the in between the two First and Second War, there was an important group of philosophers and scientists called the Vienna Circle. I don't know if you're familiar with it. At that time, one of the members, Otto Neurath, proposed in relation to the, the situation in between the First and Second War, mainly during the 30s, that you needed to have an orchestration of the scientific disciplines. So he was proposing that what we call today interdisciplinary or multidisciplinary. The idea that in order to face the problems, the new problems that science has to face, then you needed an orchestration of disciplines. Well, I can argue that in order to respond to the new conditions of the 21st century that I mentioned before, it's not enough to have interdisciplinary or multidisciplinary, but you can call it transdisciplinary. So redefining the limits of knowledge and considering scientific knowledge as part of a number of knowledges. For those, I see that two people here are Spanish speakers, so we can call them saberes, okay, as it is called in Latin America. So a choreography of saberes, of knowledges that are relevant because in the past, many of the most important problems facing humanities were solved not by science, but other ways of knowledge. Okay, so to end, just to respond to my first question, is we are now aware, I can say that science doesn't speak with one voice, but we are still have to learn that knowledge doesn't speak only the language of science. Thank you very much, and I think I managed to do it in 40 minutes. We can come back and and please, Max, you can stop sharing if you want, please.
Thank you very much, Professor Funtowicz. That was fascinating and validating personally to me. I will open the floor to my colleagues. I see that Franz has written something. Yes, maybe you can read it yourself, or do I need to read it
why
aloud?
not? It's nice. Let me listen to your voice, please, Frank.
Yes.
Oliver.
Well, I will read loud.
Hello, Prof.
Please,
I'm sorry.
go ahead, Franz.
I'm in a very loud environment, but I'm sorry if my audio is not proper. But my question
it's
to you...
It's perfect, Oliver. No, don't worry.
Okay. So my question to you is about the International Science Council. And I don't know if you're familiar with the International Science Council, but they cite your post-normal science approach.
Yes, yes, because you know I know, and I know quite well, and well, you see.
Yeah, the question is if it's possible to talk with one voice for science.
Well, I try to show that it is not, unless you decide to go back. You impose the one voice I see it. You see, and that was my second question. The first was, is it possible for science to speak with one voice? The second, should science speak with one voice? Okay, that's a normative question. And you can say that in many cases, you can impose consensus. I'm against it, but it's clear that you can, and the reasons to impose consensus are of different types, are sometimes based on a certain epistemological knowledge position, and sometimes are based on a political imperative. So you can say, oh, given all the attacks and the anti-science movements in the world, blah, 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 we have to speak with one voice. Well, you see, I don't think that works. Because this implied, I remember, and as I say, I'm old enough to remember when the discussion in the US about evolution, Darwin, and creationism. And the idea then is we have to say that evolution is the true scientific knowledge, and there is no, well, but we know today that evolution had its problems, and we have different theories of evolution and so on and so forth. So to say we have to impose consensus is not the way I would go around, because in particular in a contested world where you have such a, well, you don't have like a unified way of looking at the future. You have a total fragmentation of based on, well, on race, on religion, on sex, on gender, on etc. I mean, how can we have a consensus? on those things. And so we can go further. And we have been accused many times in post-normal science, the idea we give voice to people who express anti-science opinion. No? For example, vaccines, right? And these are very fashionable today because Robert Kennedy is now the person who decides if we are having vaccines or not. Just to clarify, I've been vaccinated because because when I was a kid in Buenos Aires, we had the polio epidemics. So
Professor Funtowicz, shall we allow another question, please?
I think, yes, please.
Please, Oliver, go in.
Okay, thank you very much, Daniel, and thank you very much, Silvio, for this very inspiring talk. I have a number of questions. I doubt that we will be able and have the time today to answer them all. I want to go from the last one that you, the last statement that you gave, that there are other languages of knowledge but science. Yeah, and this leads me to the question: how do you define science in this context? What other languages could there be? For example, I was thinking of experience could give an answer, right? What people experience, and they know that things work, and then they do this. Let's say indigenous knowledge or something comes often from experience. But in what way is experience different than science? Because it's also something that comes from observation and testing in the end. So I was wondering, I'm a bit at a loss. What else? What other languages are there for knowledge and science?
Okay, thank you very much. It's a very important question, but I don't know. It's also a complex question in many ways. So I will try. You stop me, Daniel, if you want me to finish. If you want to finish. Okay. First thing is you say science. Well, science changed over time. Okay. So what Aristotle, who invented science, thought about science was very different of Galilean science. And it lasted a long time. Okay, lasted a long time. What Galileo thought it was science is different from, let's say, ideas in the second half of the 19th century, 20th century of what science is. And now, without going into in details, but how do you define what is the method of science? Okay, and that changes. And that is, philosophers of science talked about that a lot and how that changes. The idea of Popper about refutation is different from the Vienna Circle about meaning, and it is different from my other ideas about what is the distinction between science and non-science. So in order to answer fully your question, yes, it all has to do with experience and observation, but it wasn't like that in times of Aristotle. And it's no longer like that today, where you rely on mediated instruments, which are so difficult to legitimate, validate, and calibrate, okay? So what I'm saying, that's one part of the answer. So we can talk about this evolving idea of what science is and what its method, or its methods. Okay, that's one. Let's go back to the other types of knowledge. Okay, now, when I said that some of the important problems that humanity faced have been solved not by science. Of course, if you generalize science to imply everything, then everything is science, but that's banal. And I don't think you meant that. Take, for example, longitude.
Professor Funtowicz, we are having still one question. Shall we make room for that question?
Write to me and we can talk. Let's go and then come back.
Viviana, let's make the last question, and very briefly, please.
Thank you very much. I very much enjoyed your presentation on uncertainty and uncertainty as an inherent property of the systems. But I have a more practical question, is that, so how do you deal with uncertainty in an ethical manner? How do you cope with that as a scientist, and how do you account for it in your research questions?
Yes, I think that, well, we wrote a book in 1990 called Uncertainty and Quality in Science for Policy, in which we try to develop ways to express uncertainty and also quality, because just to briefly, because Daniel is rushing. So one thing is, as I say, uncertainty is important when you handle it, when you're working in science, but it is different when it goes into a political process. What we argue is that when it goes into a political process, what is important, what it's called quality and not uncertainty. Okay, because it depends, systems have different way to respond to uncertainty. So uncertainty is not really useful when we are talking about political or legal issues, but quality. And quality is a different type of question than truth or uncertainty, because it relates an knowledge input to a purpose, okay? Purpose or function. And the question that we answer is, who decides the purpose of the knowledge input? So in order to establish how good is a knowledge input into a policy problem or decision-making problem, you have to establish is what is the purpose of that. And again, as I said before, for us, that has to be devolved to a democratic process. And this is why we concentrate so many times on crisis and conflict situation on the territory. You see? But all these questions are fascinating, and it will take me a long time to answer them. Thank you very much for having, and you know where to find me, and if you, I will be happy to answer your question.